Hello, welcome back. Today we're going to be talking about function notation. By the end of this video, you should be able to identify the dependent and independent values or variables of a function, and you should be able to use function notation. We have several vocabulary words for this section. The first one is a function of. Something's a function of something else if one variable is dependent on another variable. The relationship between the variables is a function. Let's look at an example. A child's height is a function of their age. Why? Because we have two variables, the height and the age, and one variable, the height, depends on the other variable, their age. Let's look at another example. Grades on tests are a function of the amount of time spent studying for tests. Why? Because the grades you make, one variable, are dependent upon the amount of time you spend studying, another variable. Please note that our rule still applies that to be a function, one input should give you only one output. So that leads us to dependent variable. A dependent variable is the variable that is affected by another variable. The dependent variable is often the y in the equation. Let's look at an example. When a child grows, their height depends on their age. So their height is the dependent variable because the change in height occurs only when a child gets older. In other words, their height depends on their age. The independent variable is the variable that is not changed by the other variables. The independent variable is often x. For example, your age is independent of your height. You don't make yourself get taller and then all of a sudden you get older or shorter and younger. So your age is independent. It's not affected by your height. To remember the two terms, it may be helpful to note that the independent variable can cause a change in the dependent variable, but it cannot go backwards. So your independent variable usually causes a change on the dependent. For example, time can cause a change in height, so time is independent. Let's take a look at a couple of examples of identifying the dependent and independent variables. We're going to be using the sentence stem, blank depends on blank, and then we're going to label the dependent and independent variables after we've used that sentence stem. Our first example is money earned and hours worked. We need to decide which one depends on the other. Does the money you earn depend on the amount of hours you work? Or do the amount of hours you work depend on the money you earn? Well, the answer is that money earned, and I'm going to shorten it, money depends on hours worked. Why? Because you earn more money if you work more. So the amount you work affects or changes the amount of money you actually get. So since money it depends on, that means money is the dependent variable. The number of hours worked then would be independent. You try the second example. The number of hours you sleep and how sleepy you feel. Which one depends on the other? I'm going to use the word sleepiness for how sleepy you feel. I would say the sleepiness depends on the number of hours you sleep. So since sleepiness depends on the number of hours you sleep, sleepiness is the dependent, and the number of hours would be the independent. We're now going to be writing another sentence stem, which is actually the same as the previous one, but the word is different. Blank is a function of blank. The first thing is a function of the second only if the first thing depends on the second. And for every input, there's only one output. Let's take a look. The date and the length of day. Which one depends on the other? Does the date, meaning the time of year, depend on how long a day is? Or does how long a day is depend on the date? The answer is the length of day depends on, or rather is a function of, the date. You try the second example. Some explanation first. The amount of produce and area of land. This means the amount of stuff you can grow. And the area of land means the amount of land that stuff's grown on. So which one depends on which one? Does the amount of stuff you can produce depend on the area of land? Or does the area of land that you have depend on the amount you can produce? The answer is the amount you can produce depends on the area of land. So the produce, or the amount you can produce, depends on, or is a function of, the amount of land. Or the area of land. We're now onto our last vocabulary word, which is function notation. If y is a function of x, so in other words, y is going to depend on x, and y equals 2x minus 5, we can write y using the following function notation. Y, parentheses, x, parentheses, equals 2x minus 5. The way we read this is y is a function of x, just like it was done up in the definition, or rather, when I was explaining what a function notation is. So y is a function of x, and what is that function? Well, that function is twice x minus 5. Note, the parentheses do not mean that y is being multiplied by x. They only mean that y is a function of x. Unfortunately, in math, they use parentheses over and over and over again to mean different things. In this case, when you see two letters on the left-hand side of an equation, and the first letter's outside the parentheses, the second letter's inside, and the second letter's totally by itself in that parentheses, it means that y is a function of x, or the first letter is a function of the second. So what exactly would you want to use function notation for? Looking at these two examples, hopefully that'll answer that question to some degree. Find the value of the function f of x. So again, the way we read this is f of x. We say the letter that's outside the parentheses first, f. Then the letter that's inside the parentheses gets an of before it. Then we say the letter that's inside parentheses. So it's f of x is 3 times x minus 5. So we're going to find the value of f of x when x is 4. This is going to be a little tricky because you've probably never seen this before, but let's take a look at it. Since the x is going to become 4, our function will no longer be f of x, it will be f of 4, because we changed the x into a 4, equals 3 times 4 minus 5. When you're finding the value of a function, by the way, that word is sometimes used as evaluate. Anytime we find a value, we are evaluating. Where we're finding the value of a function, we do nothing to this side. Do not change. the f of 4 stays f of 4 because we want to find out what f is, our function, when x is 4. So we merely rewrite it as f of 4 equals 3 times 4 is 12 minus 5 is, so f of 4 equals to 7. That means the value of our function f of x is 7 when x is 4. Go ahead and try the second example on your own, pressing pause, and when you're ready to see the answer, please press play. Okay, our second example, we have h of x equals 3 minus 2x, and we're going to substitute 2 in for the x. This gives us h of 2 equals 3 minus 2 times 2. Remember, we do nothing to the h of 2. We just write it as h of 2 equals 3 minus 2 times 2 is 4. So h of 2 equals 3 minus 4, which is negative 1. This notation right here means that the value of the function h when x is 2 is equal to 1. Sorry, negative 1. For our last type of problem, you're going to be asked to find the value of x that makes the following function have a value of negative 4. So we need to make our function equal to negative 4. How do I know? It's because it tells us the function has a value of negative 4. So we change the g of x, the whole thing, because that's our function, into a negative 4 equals x over 5 plus 6. So when we're trying to find the value of x, we're going to solve an equation. We changed our entire function into a separate value, and now we're going to solve. We subtract 6 from both sides, we get negative 10 equals x over 5. Then we can multiply both sides by 5, and we get negative 50 equal to x. The way you could check yourself is you could put negative 50 in for x to check and see if you actually get back out negative 4. Let's check it. G of negative 50 is equal to what value? Well, it'd be negative 50 over 5 plus 6, which is equal to negative 50 over 5 is negative 10 plus 6. Negative 10 plus 6 is negative 4. So, when x is negative 50, our function does equal negative 4. Here's another example for you to try on your own. Please press pause, work out the problem, and when you're ready to see the answer, please press play. Hopefully you've changed p of x, the entire thing, into 9, creating the equation 9 equals 5 minus 2 over 7 times x. We're now going to solve in reverse order of operations by subtracting 5 from both sides. 9 minus 5 is 4 equals, we bring down the negative 2/7 times x. To get x by itself, we can multiply both sides of the equations by a negative 7 over 2. We need to put the 4 over 1 times negative 7 over 2. These cancel, leaving us with a 1x on the right-hand side and negative 28 over 2, or we could cross reduce, giving us negative 14. As always, you can check your solution by putting negative 14 back into the equation. I'm going to leave that for you, and this should be the last example of today.